Hi there, I am back again with another Codex demonstration. Um, so this past week or so, I've made some pretty uh, big upgrades to the sort of development stack I've been working on. Um, I now that I feel like I've pretty well kicked the tires on using Codex as a development tool for writing and modifying code. Again, I used a retro project for the Tandy computer for an old computer, like 40-year-old retro computer, in using a basic language, that Basic 09, which is a old programming language, just to kind of see how I wanted to eliminate any of the sort of advantages that developing for a modern platform, you the advantage that you get by choosing something more modern with a large language model, in particular because these models are all being trained on software development, and their priorities, of course, are on programming languages and platforms and applications that are sort of used in the modern context. Um, so I'll put links in the description here for one or two of the videos if you wanted to go back and review that part of this exercise. Now that I feel like I've got a good handle on how Codex works as a development platform, I wanted to dig deeper into really the subject matter and the IT sector that I personally have a lot of passion for, and that's around open data, as it pertains to governments in particular. My personal experience has been, over these last few decades, has been focused on local government, so municipalities, cities, that sort of thing. And so I wanted to, but I'm not fully ignoring provincial or federal open data as well. In fact, I do. I've been recording some sort of personal videos talking about my philosophy about what I think these tools can enable in a modern society that have never been possible until large language models sort of hit the scene and became public access in the last few years. So anyway, what you're seeing on screen right now is a visual example of mapping, um, especially when you're dealing with local government. There's a lot of the open data that centers around information that a government manages that exists in the real world, in the 2 or 3 dimensional space of the planet. And nowhere is that more applicable than at the municipal level, because a lot of what municipalities deal with on a day-to-day basis is the management, regulation, and future planning for land use within their municipal boundaries. So I wanted to focus on a municipal region within my relatively local region. Prince Edward Island is where I call home presently. And while there are municipalities within PEI, only a couple of them kind of reach the size and scale that is a lot more common in, say, Nova Scotia and New Brunswick. And the amount of open data that's available for them doesn't reach the same level of quality as the target municipality that I've chosen for this particular exercise, which is the Halifax Regional Municipality. So what I've started to focus on is bringing in as many spatial layers as I can. If you're not familiar with mapping as a technology and how it works, is essentially you have your geography of the area that is your area of concern. In this case, that's the Halifax Regional Municipality, which here, let me open up my QGIS. So that is essentially this part of Nova Scotia. So Halifax is centered right here, the Halifax-Dartmouth area. But over this last decade or two, Halifax as a region has amalgamated into one overall municipality called the Halifax Regional Municipality. And that is defined, according to their open data, as essentially this geometry here. And within this geometry, you've got this many communities. And within, so each one of these is, here, let me select one. So each community has a name. There's Herring Cove. That's Halifax itself. This would be Dartmouth. Up here would be Bedford. Down here would be Shearwater. And what's this one? Eastern Passage. This is Cole Harbour. So there's a lot of communities surrounding Halifax, Dartmouth that are all part of this greater sort of Halifax Regional Municipality. Within this boundary, this greater regional municipality boundary, there are also community planning areas. So you have Halifax, actually, let's go to the planning areas. So Halifax and Dartmouth, and then there's a regional center, which is essentially, let me turn these off first, let me zoom in here. So within Halifax and Dartmouth, let me turn these off. That is essentially the downtown core of Halifax and Dartmouth have their own sort of plan area, where there's the way that Halifax Regional Municipality has sort of divided this up as far as land management goes is each one of these plan areas has its own zoning bylaw and municipal planning strategy. And those look something like this. So you have a municipal planning strategy for Bedford and a Bedford land use bylaw. There's the same one for Halifax mainland and Dartmouth. And then there is the one thing that's sort of changed, it looks like it's changed over a lot most recently, is that the downtown cores of Halifax and Halifax and Dartmouth have been unified into their own sort of plan area, and there's been a new land use bylaw and municipal planning strategy just for that sort of downtown core that includes the twin cities. So there's a couple of reasons why I am focusing on Halifax as a proof of concept for what it is that I'm working on. And that is, outside of that downtown core, every plan area in that map, so let me go back to QGIS here. So every one of these purple polygons has its own land use bylaw and municipal planning strategy document, and they all are roughly formatted and structured in a similar way. They're not one-to-one. There's definitely a lot of variance, including down to use of units, for instance. Like I noticed for some zones that have like a setback. So if you have a setback in your zoning bylaw, it means that generally it says you can't put a structure within a certain distance from the road. This would be usually in like a residential neighborhood. So in that case, that distance is measured in a particular unit, and I noticed in Halifax's bylaw that's measured in meters, and in the Dartmouth bylaw it's measured in feet. And this is also one of the reasons why I'm fascinated by zoning bylaws and land use bylaws in particular, is that it can vary quite a lot between municipalities, even within a region like this where it's all one unified technical regional municipality. You can have different zoning legislation that, even though it might describe the same sorts of approved uses or restricted uses for a given context, so residential or commercial or industrial, will often have, you'll see very similar sorts of residential bylaws in different municipalities. There is no unified or universal structure in how you write your zoning bylaws, and it makes it particularly challenging to try to unify what really under the covers is still talking about the same sort of thing. Like, if you want to allow lots of land within a particular zone to be restricted to certain purposes, like you can't build a house that's 10 stories tall in a very suburban neighborhood. You can't build a commercial property in the middle of a dense residential neighborhood. You can't build a large industrial park in the middle of, say, like a commercial downtown sector. That's basically what zoning does. But like I said, traditionally zoning bylaws are something that's written for a human consumption. It's not particularly friendly for computer processing as it is written. And when I was living in Victoria, my ex-wife and I at the time were working on converting the city of Victoria, and I think we may have even started on Saanich as well, to take these PDF documents and convert them into a computer readable document text format. So we use JSON, which is a JavaScript object notation format. It's just a particular format for data in a text file that can be easily read and parsed and traversed by computer programming, by computer languages, as opposed to what those documents were in their original form, which in the case of Victoria, depending on the age of the bylaw, it could be something that was you could easily read into they're all PDF documents, but you could, some of the more modern ones, you could actually pull the text out, in verbatim with proper formatting, but some of the oldest ones were effectively just a photocopy of a paper document, and so you'd need to use object character recognition, OCR, in order to pull that content out, and then have to visually compare what you got as an output compared to what the actual paper document was to make sure that there were no errors in the reading of it. So again, this is the reason why I'm going on to the Halifax region, is that all of these bylaws, and there are close to 24 zoning, like land use and municipal planning strategy documents to cover this entire area of Nova Scotia, which is roughly about 1/5, 1/6 of the province. But because other than this downtown core, all of them share basically, let me go back to this, all of them have the same sort of a title page, and they're all in the same sort of digital format. It's very easy to pull this information out using a Python text PDF to text parser. And they all roughly have a section where it defines sort of general provisions for different types of uses. So you can see here non-conforming uses or daycare facilities across the entire area that's under subject of this particular zoning bylaw. And then there will also be the actual zoning. So the way that zoning often works is you've got a zoning code. So this would be like RSU, RTU. So this is a residential single dwelling unit, which means you can only build single dwelling houses essentially. Or two dwelling units would be like a duplex. Multiple dwelling units would be more like maybe an apartment building. A townhouse would be single dwelling units, but they could be adjacent to each other in a sort of a row, I think. Anyway, you've got like shopping centers. So this would be like a mall. You could have Main Street commercial for like a downtown or an urban center. Light industrial zoning. So each one of these zones has its own section that defines what you can do. So let me just choose heavy industrial first. So each one of these zoning documents has sort of a list of what are the things that you can put inside of properties within this zoned area. So here, a heavy industrial zone is for things like warehouse and storage, manufacturing, processing, assembling, or warehousing, railway use, parking and storage of industrial heavy commercial vehicles, trade centers, recycling facilities, construction industries, that sort of thing. Whereas if you went back to, say, a residential single dwelling, here, single detached dwelling units, semi-detached, duplex, linked dwellings. Up here, single detached, neighborhood parks, uses accessory to the foregoing uses. So all of this is written, again, the same details can be covered for, like a single dwelling unit zone is a fairly common type of zone inside of municipalities, but the way that it's written, even though the details might all be present when comparing municipality to municipality, it can be there is no standard in how it that gets recorded, or how even down to the naming of sections and clauses. So here we've got here there's actually no section name for this RSU zone, but it has a number of clauses that are sort of each one of these defines a specific use, permitted use for this particular zone. And some of them may have been repealed. You can see this one used to be here, but it got repealed as of June 2024. Then there's also a lot of numerical data. So minimum lot area. You can't have a lot smaller than 6,000 square feet for this type of unit. You have to have a frontage of 60 feet. So that means you have to have between any structure and the road 60 feet worth of space. Minimum front yard, 15 feet for local and collector streets, 30 feet for arterial streets. So local and collector streets are sort of less used roads. A local road is something that is essentially just meant for local traffic. A collector is a road that's used to collect all these local streets and neighborhoods and feed them into something that's more like an arterial street, which is the third option here, which is essentially you get, and this is again both municipally and provincially, you have this concept of a local street, which is essentially just for local traffic, a collector, which is a way to start collecting traffic from a bunch of local streets, and then arterial streets are ones that collector streets feed into, and they're more like main roads within a municipality. So that would be like your downtown streets or the streets that lead from suburban communities to downtown. And so here you can see you're allowed a 30-foot, you have to be at least 30 feet, 30-foot front yard in arterial streets, 15 on local and collector streets. So you want to make sure that and that's probably due to a noise thing where you have, so I've got frontage wrong, but effectively, if you know that an arterial street is going to be busier than a local or a collector, there's going to be a lot more street noise. So you don't want developers building houses too close to the road, because the people who buy it will complain about the noise. And so that's again why that's distinguishing between arterial street front yards versus local and collector streets. Anyway, like I was saying though, most zoning bylaws will have these sort of minimum lot areas, minimum front yards, rear yards, side yards, again, to give you that distance from not just the road, but also from your neighbors, to ensure us a minimum amount of privacy for residential owners when these properties get developed. So a lot of this is rules and regulations that are applied to developers who want to build new housing within a residential area, they have to adhere to the bylaw. Now, the reason why I'm kind of going into this detail is like I said, there is no uniform structure, and these are written for human consumption. They're not something that's easily parsable by a computer. And if you wanted in the past to convert these zoning bylaws into something more uniform, which in computer programming is called normalizing, where you get like types of data stored in the same type of field, the same type of unit across all data sets within your database, that would have required a lot of human effort, because you can't just codify it, because especially when it varies down to the municipality and sometimes down to the zoning bylaw. For instance, you can see here, originally this was probably this use case, this one, and this one, but at some point there was an amendment. So on May 23rd, 2024, and then accepted on June 13th, 2024, they made an amendment to this zoning bylaw to add an extra clause in here that says all uses permitted in the RTU zone within the urban service area. So this is a specific spatial area within this Bedford municipality. Subject to the RTU zone's requirements, it allows residential single dwelling unit zoned areas to have the same uses permitted within this zone. And they added this, and there's no reason why this had to be added here. It could have been added to the bottom, other than there's maybe some sort of business conventions that the planners at the municipality of Bedford chose to insert it here, but they chose to use AA to be able to differentiate it. If they want these to sort alphabetically, they can't. There is nothing between A and B, so they have to create a new code. Well, I've seen in the Halifax zoning bylaw or land use bylaw, this could be A-1 or A1 or A.1, and again, there is no universal convention for inserting clauses in between other clauses, what that format looks like. So again, the reason why I like focusing on zoning bylaws in particular and municipal planning strategies is, again, because they're all trying to solve the same problem, but because every municipality has its own sort of internal standards, and those standards evolve over time. In 2024, when they want to add a clause between A and B, they use AA. Maybe 10 years ago or 15 years ago, that was A1. Maybe they use a different thing. And then this might even vary down to the individual planner. The person who chose to insert this may have chosen a different code for this clause based on personal preference. So this is the perfect kind of data for me, from my perspective, to try to train large language models on converting from what's effectively a human targeted resource into something that can be understood by a computer and normalized, so that the database that contains all of these zoning bylaws and all of these municipal planning strategies across an entire region, or across the entire province, or across the entire country, or across the entire world, you can start to look at ways of automating this pulling in of this information, normalizing it so that we pull out all the important details and make it so that you can start to build queries, including tying these sort of text-based contents, which would fit into database tables, marry it with the actual spatial data, which in this case is these. So that Bedford land use planning area or planning document and the matching municipal planning strategy document. So that's the land use bylaw. There's also the municipal planning strategy for Bedford, which also has a whole bunch of definitions about how they plan to improve their street network, their main commercial core, improvement district, waterfront development, and then secondary planning for land use, street hierarchies. This planning strategy out in BC, these would be called official community plans. I think in PEI they're also called official community plans. But this is effectively the same thing, where generally with land use regulation and planning, you have not just these zoning bylaws that define what can be built in the city or the municipality today. There's also some future-looking document that guides how they want the overall area to evolve in time, especially when you're dealing with a rapidly increasing density. You want to make sure that density happens in ways that are sustainable, that don't that discourage sprawls. You want to make sure that your commercial and your dense residential developments happen all close together within urban cores. You don't want to have heavy, dense residential spread out to your suburbs, because that's going to impact things like traffic. If everybody's driving in from large residential suburban neighborhoods, all of a sudden your roads need to be heavily upgraded to be able to handle the traffic, and you also deal with lots of issues of getting your transit vehicles through, because they're going to get caught up in heavy rush hour traffic, both going into town in the morning and going out of town in the evening. The fact that every municipality in North America, well, at least in the United States and Canada, should have this type of documentation both available to the public and probably available online in some sort of digital format, usually PDF. But because there's no consistency in this, it's very difficult to do large-scale analysis or be able to build systems that are cost-effective, that can help both local residents, local developers, local council members, and staff to really qualitatively and quantitatively assess how their particular municipality is operating in comparison to other municipalities, and whether they're doing a good job of sort of growing these municipalities responsibly and with careful detail. Is there a lot of spot zoning going on where different developers come in and want some special exclusion that doesn't fit within a zoning bylaw? Is their municipality creating one-off zones for particular developments? That's generally a bad practice, as opposed to building new types of zoning that can be applied for new types of development, should those kind of come across in the future. So this gets me back to what I've been sort of playing with. Let me go back to Codex here. So this leads me to what I've been working on this past week, which is using the Model Context Protocol, or MCP, functionality that's available in tools like Codex. So MCP, or Model Context Protocol, is a standard that's been adopted by some of these OpenAI and Anthropic and some of the other model companies as a sort of a non-platform specific way of connecting large language models to various software products, or even software features or hardware features like file system access. And in particular, I've been focused on two MCP connectors for my Codex project, which so I've created this MD Open Data Modern Democracy is my sort of brand that I've created for myself that focuses on the use of technology in increasing openness and transparency on government data. So I created this MD Open Data project, and within it I got the model to do two things for me. One, I got it to install a Docker installation of Postgres and PostGIS as so Postgres is an open source SQL-based database. PostGIS is sort of the spatial layer that sits on top of it that allows you to put in spatial data layers. And so it set that up, and it has direct connection to that database. In fact, I'll show you, let me scroll to the bottom here. So I can do a query to say list the MCP resources, and it tells me here's all of the tables and views that are available and spatial layers that are available through this Postgres database server. So a lot of these HFX prefixed, these are spatial layers. Anything that starts with a capital HFX underscore is a spatial layer that's coming from the Halifax Regional Municipalities Open Data portal, which is on Esri's ArcGIS online portal. And these are freely downloadable spatial layers. That's what we were looking at in QGIS here, were two of those layers, the community plan areas and then the community boundaries one here. Both of these are open data layers that you can get, you can download for yourself that cover the regional municipality. In addition to that, there's a number of database tables that I've created that have pulled in. So what the other thing that I've been doing is taking those PDFs that I was showing you, and I started with Halifax and Dartmouth. I've got Bedford and I've got Cole Harbour done right now, and I'm planning on over the next week or two pulling in all the other. I've got them all downloaded. I just need to go and do the process for each one of them for the zoning and for the municipal strategic planning documents. Putting them into JSON documents, which here I'll go to my code for this. So in data, I've got zoning folders for these for Cole Harbour, Westphal, Bedford, and Halifax, Dartmouth, Halifax mainland. And in each of these, I've added a, so this is the land use planning folder, and then I've also got a municipal planning strategy folder with the same sort of breakdown. And each one of these I've created separate JSON documents for each of the actual defined zones. So in Halifax, this is the C1 zone, and you can see it's got, so this is the local business zone. This is just, and then there's some contextual information about where it appears within the PDF. But then as we get down here, you can see it's got permitted uses. So each one of these is, so the different, so this has the, this C1 zone allows all the same zone uses that R1, R2, R2T, and R4 zone uses, as well as store for retail trade, rental or services, motor vehicle dealers, adult entertainment uses, amusement centers, commercial use. So this is all permitted uses that this municipality, this particular zone allows. So everything that's defined in that particular zone entry, as well as schedules. So these are more about specific spatial areas that are referenced within the rest of the document, and there may be some details. So these schedule documents themselves do have some additional detail related to zoning and land use. And then there's also a few things. There's a definitions document, which is at the beginning of each one of these documents, there's a definitions block that gives you the term as well as definition text. And I'm also working on adding links into all of the zones and schedule documents that link to these definitions, so I can start to automate that linking as well. And then on the provincial, the municipal planning strategies, the same sort of thing. Here we've got sort of sections about how, so there's, in the Halifax one, there's like basic approach and overall objectives, there's citywide objectives, and it sort of breaks it all down. So this is all content that's relevant to both the current acceptable uses and future planning uses, so that if a developer looks at these two documents, they can then see, oh, well, we have access to this land, and it may not be zoned for this particular use right now, but according to this municipal planning strategy, this is an area, an overall region of that municipality that is asking for this type of thing. We can go to the province, to the city, sorry, and apply for a rezoning application and go through that process. Basically, I've got my large language models automating all of this conversion. So it's using Python's, there's a Python's programming language, and there's a PDF to text plugin for Python that the model is using. It's got scripts that it's created. That's what these import Python scripts are, and it's basically pointing to the original PDF, which I've got here in docs. So I've got all of these municipal planning and land use bylaws. I've named them in a consistent fashion. It's not the file name that was downloaded, but I've renamed them all. And as you can see, there's a whole pile of them for the HRM for each of those polygons in that planning area layer that I was showing. The other thing that I've got going, so essentially I have started automating the conversion of PDF to JSON documents. One of the steps I haven't gotten around to is now sort of, once I get all of these PDF documents pulled into JSON documents, the next step for me is to normalize it. So I'm going to start pulling out common attributes and use cases for different zoning types from each of these different municipalities, and then come up with a conversion plan to take the content that's structured according to the actual published document, and then create a parallel document that has the exact same content but structured in a uniform way, so that that can be pushed into the database tables, so that I can start to do queries across municipal region, like boundaries, or planning area boundaries in this case, and start to generate maps on top of that really demonstrate the power of this type of an exercise. The other thing that I got as far as MCP is concerned is, so QGIS is an open source spatial workflow tool, similar to, so the biggest player in the mapping space on right now is Esri. Esri has a desktop application called ArcGIS Pro, which is essentially a tool that lets you pull in spatial data from local files. So when you download from the open data portal from Halifax, and from any of the Esri open data ArcGIS online portals, you can download it in specific file formats. There's lots of different spatial file formats, from proprietary ones like shapefiles to open source ones like GeoJSON, that basically has the polygon shape. So this sort of a polygon is defined by these straight and not so straight lines, as well as any sort of holes in the polygon, in the shapes. That's all stored in a digital format, as well as a whole bunch of attribute data. So you can see here with this Bedford one, all these attributes. There's a global ID, object ID, plan ID. Actually, the global ID might be database specific, but there's a plan name, this is Bedford. There's an alias field, in this case is not set. Source comes from planning. I'm not sure what the SACC acronym attribute is, but there's a bunch of attributes tied to a polygon in addition to the spatial data. You can also pull this from a database. So in my case, I've got my Postgres SQL database, my PostGIS database, and then you can see under HRM, there's a bunch of views here, as well as in my public one. This is where all these spatial layers have been imported. So these are all the Halifax. All these HFX ones are ones from civic addresses, which I can pull and put on here if I wanted to. So that's all these address, every legal address, every civic address in the whole HRM is on that layer, and that's what all these points are. Essentially, they're a specific dot on the map. If I zoom in a little bit, you'll see. So each one of these represents a specific residency, and you can see the details of it showing up here. So it gives you all sorts of. This is often used by emergency services, but it can be used for all sorts of applications. You've also got, let me turn that off. community boundaries, council boundaries. So it looks like, let me pull this over for a second and zoom out. So it looks like that the way that the Halifax Regional Municipality is set up is that it's got the entire area divided into 3 community councils, I think. So there's Halifax in the west, there's Harbour East and Marine Drive, and then there's the Northwest, which I would guess, again, I haven't looked into the actual sort of the organizational structure of HRM to this level, but just based on this particular map, I'm assuming that there are essentially 3 different elected councils that handle, and I'm assuming this is not, yeah, it's not, okay. It's just we've got 2 different polygons showing up here. Oh, is that? That's exception. Okay, so that might be your downtown Halifax. What is that? Yeah, downtown Halifax has its own exception. So essentially, that's what it looks like, is that there's an actual different legislative body that manages these 3 big parts of the HRM, and then there might be a small exception for the downtown of Halifax itself. That if you wanted to do a rezoning, or you wanted to change your land use, or you wanted to apply to construct something that even you didn't necessarily need rezoning, but you needed community approval, those are the actual political bodies that you go to get that approval. There's a street network layer, so this one's actual lines, which should not showing up for some reason, but either way, there is a street. It's a line layer anyway. For some reason, it's not showing up. I probably don't have it colored right. But zoning boundaries. So this is the actual zoning map. So each one of these represents a different zone. But it may not be down to the individual, like especially these big areas. This is a regional park, but this one here. So this is this particular parcel of land, which, well, area of land could contain multiple private lots, but they all fall within the same zoning code, which in this case is DH. This type of a tool lets you do all sorts of mapping, analysis, editing. You can create queries and views by combining multiple layers to get different types of input. So for instance, I've created one here. So these are within Halifax and Dartmouth. These are all of the areas that have a single family and accessory building permits according to the zoning bylaws. Now, this is not necessarily fully accurate. This is me kind of playing around, but to give you an idea of why I want to do this type of work, by unifying all this data, you can start to do cross-boundary queries. So this, again, I'm not fully certain I've got my query fully accurate because I haven't normalized the data, but this is an example of, here's all of the, according to at least the way the data is currently mapped in my table structure, all of the parcels, all the zoning boundaries, so these areas that, like I said, could contain multiple parcels of land within the same boundary, but each one of these has a zoning code that permits single family dwelling to be built on. And this is going both Dartmouth and Halifax. Ignore some of the bleed over here. Again, I think that's a querying issue. Just to give you a little bit of a demo of the types of things you can do by unifying all of this data and taking the text-based content of zoning bylaws and marrying it with the actual spatial layer that's the open data. Like I said, both of these are open data content. One is just purely text with no direct spatial connection other than it matches a zoning code, and there is a separate spatial layer that shows the entire geometry of the municipality and what zoning code each of those parcels or regions, zoning boundary areas adheres to. So if I dig into one of these, and click on it, you can see it's got an R1 zoning code, which means it's resident single family dwelling. So the last thing as far as the MCP side of things that I wanted to demo here is the other thing that I've also hooked up through an MCP connection. Again, that's the Model Context Protocol. I don't just have my Codex connecting to the database where it can do table queries or spatial queries directly off the QGIS database. I've also got it interacting with QGIS, so it can actually set things. So let me see if I can get this to work again, just to show you. Map highlight all Dartmouth features with zone code R1. Let me do that. So it's going to think. So it's going to look at all of the Halifax zoning boundaries features inside the Dartmouth feature where the zone equals R1. So now it's going to do this query, and then you can see here it's done that exact query on the Dartmouth boundaries. So in fact, this is a good demo of how my sort of unified view is working, is that it's showing you every single one of these is R1. So these ones here that are also part of Dartmouth, or at least these ones, are also single family dwelling, but they're not R1. But this highlighting was done by the model. And then I could see, I can also get it to do something like this, render the current map view so I can inspect the R1 highlights in chat. So now it's connecting to QGIS, pulling the actual rendered map, and it's boom, put it on screen for me. So I can actually not just do table queries off of the QGIS, the PostGIS database. I can also, using QGIS as an application and the interface between it and the model, I can actually have a conversation with the model that does the visualization in QGIS and then brings it into the chat. This in particular, I think, could be quite valuable for both presentation purposes. If I wanted to sort of do some live work with the team, instead of exposing them to this type of view, which you can be a little confusing, especially for people that aren't technically familiar with QGIS, having all these extra, button panels and side, text attribute fields and contextual windows. You can just take the spatial map and have it rendered on screen. So, and this could also be used in a live deploy. Now, QGIS is just one particular example. There's no reason why you couldn't build a MCP connected, customized visualization tool that does a spatial query and visualizes it within of a chat window, and so that anybody could hook up to it over the web, for instance. So you could actually create a plugin for people that want to use this within their own codex. Alternatively, you could also use open web tools to generate a web window, like an actual canvas, and I think there are ways to be able to put it within the chat conversation as well, but that's something else I haven't looked into. Again, this is more sort of a proof of a concept, kicking the tires and just sort of figuring out what's available. But the fact that I can both, just by talking to the model, I can get it to go from taking a PDF that I've downloaded onto my computer, pull all the content out into a JSON format in the same folder structure, import that data into the Postgres database, then connect to QGIS and connect and marry that data with a spatial layer, or create a materialized view on the PostGIS side that connects both the tabular data we've imported with another spatial layer, and then creates a materialized view that can then be pulled into QGIS and visualized, and then do selected queries an interface and then pull that visualization into the chat. All of that is done by the model. I'm not having to do any of the heavy lifting, and even the wiring work of setting up and connecting the database and setting up QGIS, although I think I probably did the software install myself, but doing the actual MCP connection, interestingly enough, the MCP protocol implementation that it started with was based on QGIS 3, and the QGIS version I have on my computer is QGIS 4. It actually went and rewrote that protocol, that Python protocol, and updated it so that it worked with my version of QGIS. And now all of this works from, like I said, so I can go from PDF through to visualization on screen, marrying that text data to a spatial layer. And all of it's automated. All of it is controllable by just talking to the model in a human language type interface. This is a revolutionary way to look at working with spatial data, and it's still early days. Like, there is so much that can be built on top of this type of a stack that would both speed up the work of people who are spatial analysts, but also expose this spatial and non-spatial content to non-technical people in ways that completely changes the way that people work with data. So anyway, I think that's about all I wanted to cover for this video. I just wanted to kind of show off what I've been learning. The MCP protocol, Model Context Protocol, covers way more. It essentially allows the model to connect to any type of software-based system or hardware system. And in fact, I believe under the covers within Codex, it's probably got MCP-like connectors for accessing the file system and doing web searching and that sort of thing. But there's no reason why you couldn't create your own MCP connection to your own customized solution. So if you have a custom database or a custom web interface or a custom REST endpoint that has your own personal or corporate or organizational data, it's rather trivial to set up a connector that exposes that information to a model, and then you can just talk to the model and get it to do a lot of the heavy lifting work that in the past would have required people with large amounts of IT knowledge. So whether it's writing SQL queries or creating HTML source pages and JavaScript, TypeScript, that sort of thing, or understanding really complex software tools like QGIS or ArcGIS Pro. And there are, I believe, MCP. I don't think it's anything that's Esri official, but I believe there are MCP implementations that would allow you to connect to everything that Esri currently provides as a product on the spatial side. But I know there's, like I said, it's not just limited to the IT sector as far as software is concerned. Any type of software you can think of, there's no reason why there couldn't be an MCP connector that allows a model to connect to it and completely change the way that you interact with your software. So anyway, that's what I've learned this week. Incredibly valuable, incredibly powerful. This is just the beginning of what I can do with this stuff, and I'm really looking forward to kind of continuing to play with this and to work at, like I said, my long-term goal for this little prototype is to pull in every zoning, the very long term is to get every piece of open data, whether it's legislation, regulation, or spatial data that's available for within the HRM, into a unified database and start looking at how can I create interesting connections, whether it's just mapping tables to each other or mapping spatial layers to tabular data, and then building materialized views that can then be knitted together and perform complex queries that do really interesting spatial analysis or just data analysis, not just within a municipality but across an entire region like this, and then scope that out to incorporate more and more municipalities, not just within Nova Scotia but within the Atlantic provinces, eventually Canada and elsewhere. So if you find this stuff interesting, please give this a thumbs up or a like and share it. If you're interested in helping me out or just providing some level of support, reach out to me, and I will be back in the near future with sort of following up on where I get with this once I get a little more further down the road with the data ingestion and normalization of this pretty complex content. So thanks for watching, and I will see you next time. Bye-bye.